let's talk about functions in the complex plane. What that means is the input of these functions are complex number and the output is also complex number. A function is essentially an input-output machine. Maybe you have learned this before. Any function f is an input-output machine. It can do things like squaring. So if I input the number 3 here, the output will be 9. So the set of input values, often known as the domain, and the set of output values, often known as the range. In this case, we can choose it to be real numbers. However, we have a function here where the set of input values and the output values are complex numbers. So if you input a plus ib, this complex number in this function, the output is e to the power a times cosine of b plus I sin b. We have to check whether this function is 1-on-1 and on-to. This is a very interesting problem from ISI Entrance 2023. We will learn a lot using this problem about the geometry of complex numbers. The geometry of complex numbers. I will also give you a challenge problem in this video so that you can try it and put the comment in the comment section. So let's get started. The first thing to realize is what is the geometric meaning of this output. What is the meaning of this output? Let me draw a picture. I'll draw the XY plane, or sometimes known as the Argand plane, where every point can be regarded as a complex number. So if you have the point 2, 3, you can rewrite it as the complex number 2 plus 3i. So every member of this plane is a complex number. So if I take cos b plus I sin b, then it's just the point cosine b comma sin b. The x coordinate is cosine b and the y coordinate is sin b. And you can easily calculate that the distance of this particular point from the center is cosine b square plus sin b square, square root of that. I'm just using the distance formula. We know that cos square b plus sin square b is 1, so this is 1. Therefore, the distance of this point from the origin is 1 unit. Hence, I can write this as points on the unit circle. In fact, if you just change the value of b from 0 to 2 pi, if you change the value of b from 0 to 2 pi, you will just get all the points on the circumference of this unit circle. What happens if I multiply this with e to the power a. What happens if I multiply this with e to the power a? What happens to the point? Well, e to the power a will act as a dilation. It will either elongate or contract. It will elongate or contract the vector. So what that means is, let's say if e to the power a is 0.5, for some value of a, it will be 0.5. Then instead of situating on the circle with radius 1, this particular point, cosine b comma sine b, it will be reduced to a circle with radius half, and it will be same point. I mean, the inclination of this segment with the x-axis will be the same, but its length will just change to 0.5. So what happens if if e to the power a is 23? Remember, e to the power a can never be negative. Power of e cannot be negative. It can't be 0 either. E to the power a is not equal to 0. But what if it is 23? Well, then you'll get another circle whose radius is 23, and now the same point will be here. So you see what's going on. This radius is 23, of course. Multiplication by e to the power a simply changes the radius of the circle on which this point is. So in this way, you can get all the points in the plane. How can you do that? Well, suppose you want to get this particular point on the plane. You want to get this point as the output. How can you find an input such that the output is this point? Well, first thing, draw a circle with this radius. Join the point O with this point P, which you desire as the output, and draw a circle with that radius. Suppose this radius is 44. I'm just making up a number. Then you want e to the power a to be 44, or a should be ln 44, the log of 44, log base e of 44. I'm just taking ln on both sides. I'm taking log on both sides. So a should be that, and b should be this angle in radians, whatever this angle is. Maybe this angle is 120 degree. Maybe this angle is 120 degree. Or b is equal to 2 pi by 3. So you found the input point. The input point is ln 44 plus I 2 pi by 3. For f of that will be e to the power a is this point, this number, times cosine of 2 pi by 3 plus I sine of 2 pi by 3, which will precisely give you this point. So for this particular output point, I found an input point, which is ln 44, plus I 2 pi by 3. And you can precisely find the value of ln 44 using a calculator. So ln 44, I have calculated it from before. ln 44 turns out to be 3.78 approximately. And 2 pi by 3, 2 times pi by 3 is approximately 2.09. It's very important that you understand this, how this map is working. So to do that, I will just draw two complex planes or xy planes. This is the input plane. The input values are coming in from here. And let's make a copy of this. Let's make a copy of this. And let's change the color. So in the top plane, when the input is approximately 3.78 and 2.01, so maybe it is 123.78 somewhere here, and 2.09 is like this. So maybe this point in the plane maps to, so let's call this the input point Q. This maps to the output point here, which is 44 times cosine of pi by 3, 2 pi by 3 plus I sine of 2 pi by 3. So the point in this plane, the input point here, maps to that output point. Okay, so that's pretty good. It's actually quite good. We found an input point corresponding to this output point. But the question is, will more than one input point work? Can more than one input point produce the same output point? Well, we know that we have to keep ln 44 to be the value of A, which is approximately 3.78. So this x coordinate should be 3.78 always, to get this particular length of the radius, approximately 3.78. But what about the angle? We chose the angle to be 2 pi by 3. What if we choose the angle to be 2 pi plus 2 pi by 3? So instead of 2.09, what if we have 8.37 approximately? This is approximately 8.37. So it will be a bit higher along this line. So this is 2.09. And if I go a bit higher, like here, where it is 8.37, then this point will again map to the same point. Because you just found the same angle plus 360 degree, right? This angle was 120 degree. You rotated it by another 360 degree. So you now have 360 degree plus 120 degree, or in radians, it will be 2 pi plus 2 pi by 3. So not only this point maps to here, this point also maps here. And now you can see the pattern. This entire vertical line, this line is an infinite line. It will keep on wrapping around this circle of radius 44. This is very important to understand because it's a very beautiful visualization. This line in the input complex plane gets continuously wrapped around this circle. Isn't it very nice? I find it very beautiful actually. And every time there is a gap of 2 pi, which is approximately 6.28. Every time you have a gap of approximately 6.28, you return back to the same point. So in particular, more than one point will work. So this map is not one-on-one. It's not one-on-one. Moreover, it's not onto. Onto means, we will show that it's not onto. Onto means all points in the codomain do not have input values, input points that produces that output. So, I mean, you will be able to find some point here in the downstairs. You will be able to find some point in the downstairs. Maybe this one. Actually, this one will be not that point, but maybe this one, for which we won't be able to figure out an input point upstairs. That means no input point upstairs can produce this particular point. No input point upstairs can produce this particular point. So what point is that? What point cannot be produced in this fashion? Well, that is the point in the origin, 0, 0. You cannot produce 0 plus 0i as the output using this function. Let's understand this geometrically. You cannot have this equal to e to the power a cosine b plus I sine b. Cosine b plus I sine b is just the unit circle or a point on the unit circle for a specific b. Changing b, you will get all the points on the unit circle. E to the power a is the scaling factor. It will contract the circle or expand the circle, as we talked about. But it can never contract the circle to the point that e to the power a is 0. That can never happen. The exponential function, if you remember the graph of it, is like this. This is the graph of e to the power x. So it never touches the 0 point, the 0 height. It never achieves the 0 height. Power of the number e, even if you take negative powers, it will become very small. It will become very small, but it will never be 0. So this circle can never be shrunk to the diameter 0, which means that this point cannot be produced. Hence, the function is not onto. All the points in the codomain are not produced in this manner. But I'll come back to this picture one more time. And I'll ask you a challenge question. Where is this vertical line? Where is this vertical line mapped in the downstairs? Where is in downstairs, where is this vertical line, the y-axis, is being mapped? If you can answer this question, put it in the comment section. I'll check it. Thank you for watching this video. I think this was very interesting and exciting. I will see you in the next one.